All right, we're going to talk about proving angles congruent today. So we're really delving into proofs. So vertical angles theorem. So here's our diagram. Hopefully that's not too light. Theorem is a conjecture or statement that you prove true. So vertical angles theorem, vertical angles are congruent. So angle 1 and angle 3 are congruent. Angle 4 and angle 2 are congruent. So we are going to prove that angle 1 is congruent to angle 3. Okay? So we have our two-column proof here. Okay? So what we're going to do is we're going to look at, first thing I'm going to write down is my given. Angle 1 and angle 3 are vertical angles. Given. Okay? So now I'm going to look at here, and I'm going to kind of do a little bit of information from my diagram. Okay? So I'm going to kind of come here, and I'm going to say measure of angle 1 plus measure of angle 2 equals 180. Well, why do I know that these add up to 180? What is the reason for that? Well, they're a linear pair, right? Okay. Well, I need to get angle 3 in here some way too. So I'm going to say that angle 3, so the measure of angle 3 plus the measure of angle 2 is also 180, right? And the same reason, it's a linear pair also. Well, if I notice here, I have two things that both equal 180. So what I'm going to do is I'm going to substitute measure of angle 3 plus the measure of angle 2 in for 180. So I have the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. Okay, and this is just substitution. Okay. Now, what do we have that's in common on both sides? Well, we have the measure of angle 2 and the measure of angle 2. So I can say the measure of angle 1 equals the measure of angle, not 2, of 3, right? And what'd you do here? You just had subtraction. Right? Now, we're not to where we are. This says we have congruency, but we're at equality. Well, the nice thing about equality and congruency is they go hand in hand. So I can automatically go from equality to congruency, and that's just the definition of congruency, okay? So here I took my theorem. I proved my theorem is true. They're vertical angles. I proved that they are congruent. And so now I get to use that theorem, okay? So that's kind of an example of how we would prove a theorem to be true. Okay, so here we're going to use vertical angles. So I'm going to go ahead and erase this real quick. And so I have measure angle 1 is 2x plus 21. Measure of angle 3 is 4x. So now I want to find, remember that vertical angles are congruent. So I know angle 1 is equal to angle 3. Now I can go ahead and substitute in. So I'm going to substitute in. I'm going to set these equal to each other. 2x plus 21 equals 4x. And I'm going to solve. So what I'm going to do is I'm going to subtract my 2x over. So I have 21 equals 2x. I'm going to divide by 2. So I have x equals 21 over 2. If you wanted to write that as a decimal, that's fine, 10.5. I typically will leave things in proper form. Okay? So proof using vertical angles theorem. So here we have our given. Let me find out exactly where those angles are. Okay, so there's where our angles are. So 1, 2, 3, 4. So I'm given that angle 1 is congruent to angle 4, right? So I need to prove that 2 is congruent to 3. So the first thing I'm going to do is write down my given. Angle 1 is congruent to angle 4. The reason is given, okay? So that's good to know. Now, what else is angle 3 or angle 1 equal to? Well, angle 1 is congruent to angle 3, right? Because of vertical angles are congruent. You notice I'm kind of shorthanding a little bit. That's okay. I need to state what angle 4 is also congruent to. So angle 4 is congruent to angle 2 by the same reason, right? And so now, anywhere I see a 4, I'm going to put a 2. Okay? So I'm going to go, so angle 3 is congruent to angle 2. This is substitution. Okay. Notice that it is not in the same order up here. That's okay. I can always flip it. I could have flipped it right here and still said substitution, but I'll flip it here. And this is the symmetric property. Okay. So that's using vertical angles to prove that these are congruent. Okay. Congruent complements theorem. If two angles are complement to the same angle or congruent angles, then the two angles are congruent. So if I know angle 1 and angle 3 are both complement to 30 degrees, okay, I know that angle 1 and angle 2 are congruent. Right angle theorem. All right angles are congruent. Remember what a right angle is? Right angles are 90 degrees. All of them are congruent. If two angles are congruent and supplementary, then each is a right angle. So this is basically kind of like a linear pair where they're congruent. Paragraph proof. So a paragraph proof, instead of, so if I were to take 2x plus 1 equals 5, right? So my process in a two-column proof would be something like this. So this would be my given. And then I would have 2x equals 4, subtraction. And then I'd have x equals 2, division. Okay? That's kind of like a two-column proof, right? So I'd have my statements, here I'd have my reasons. Well, paragraph proof would be actually physically writing out with sentences. Start with your given equation of 2x plus 1 equals 5. Then subtract 1 from both sides. Getting 2x equals 4. Put a semicolon there. Okay? So you will then divide each side by 2 and find your answer to be x equals 2. I don't talk a lot about paragraph proofs because they're just physically writing out the sentences. And you can kind of see sometimes it takes a little bit of time to write those paragraph proofs. Okay? All right, joke time. What cheese does a cow like? Mozzarella. There are two men on two different trains on the opposite sides of a 10-mile railroad track. One train is traveling at 50 miles per hour, and the other train is traveling at 40 miles per hour. Where will they meet? At the hospital. All right. So that's proving angles are congruent.